Hello everyone, in this video we'll be solving problem 637, average of levels in binary tree. The problem statement is, given the root of a binary tree, return the average value of the nodes on each level. In example number 1, at level 0, we only have one root node, that is 3, so the average will be 3. One level deeper, we have two nodes 9 and 20 whose sum is 29 and average will be 14.5. At level 2, we again have two nodes 15 and 7 whose sum is 22 and average is 11. Concatenating the three averages into a single array, the output will have 3, 14.5 and 11. This is a very easy problem and I'm sure you must have realized it as we were trying to solve this problem using example number 1. Let's switch to whiteboard and discuss the solution while calculating its PEGO notations, that is the time and the space complexity. The simplest solution here is to maintain a map of type integer and list of ints, where this int is going to be the level or depth of the tree and this list of ints will be the number of nodes in each level. As we need to calculate the average of all of the nodes at each level, we either need to maintain the list of all of the numbers at each level or the sum and the total numbers. In other words, I can save the values 2 and 20, or I can save 22 as a sum and node count, that is 2. With either of the approaches, we can easily calculate the average at the end and build our result. Let's run a couple of simulations to understand how will this work and save the node values as we iterate. We start the iteration from root node whose depth is 0. As level 0 does not exist, we'll add it to the collection. As the order in which we are processing the nodes doesn't matter, we can either go to the left or the right. For simplicity, let's go to the left node. As we are going one level deeper, we'll increment the level by 1. So L is equals to 1. We are at node 2. As L is equal to 1 does not exist in the collection, we'll add it. Let's continue with the traversal by going to the next node, which is node 1. The level will be 2. Similar to what we did for the left leg of the root node, we'll repeat it for the right leg, but at this time, each node will be added to an existing entry because level 1 and 2 have already been covered. So at level 1, we'll add 20 and at level 2, we'll add 15 and 30. Now that we have completed the iteration of all of the nodes in the binary tree, all we need to do is iterate through this collection, add all of the values at each level and calculate its average. For level 0, the average will be 3. For level 1, the average will be 22 divided by 2, which is 11. We'll repeat the same operation for level 2 and level 3 and save its corresponding averages in a different collection, which will be returned at the end. With this solution, our time complexity is O of n, where n is the number of nodes in the given collection, and the space complexity is O of m, where m is the maximum depth of the given binary tree. This is because we are maintaining a hash map for all of the nodes at each level. I hope you were able to understand this explanation. Let me show you how we can implement this using C#. Here is the C# solution. I start by initializing the dictionary of type integer and a tuple of int and long. Contrary to the solution that we discussed earlier, here I will only be saving the sum of all of the nodes at each level and the total count. I then call the DFS method passing the root node, the current depth and the map, which will hold all of the values. This DFS method first checks if the given node is null or not. If it is not null, then I check if the depth already exists in the map. If it exists, then I'm taking the sum of the past nodes that we have calculated and adding the current node to it, and also incrementing the node count value. And if the key does not exist in the map, then I'm creating a new tuple and adding the current node with count as 1. Post that, I'm calling the DFS method recursively, passing the left node and the right node, and incrementing the depth value by 1. Once we have iterated through all of the nodes, I then start a new for loop on the map, calculating the average at each level and saving the output in the results variable, which is then returned at the end. This code, when submitted on LeetCode, beats nearly 96% in terms of runtime and 6% in terms of memory consumption. Thank you for watching this video. I hope you were able to understand this explanation and the source code. The link to the code is available in the description below. Feel free to check that out, and I will see you in the next one. Thank you.